Now that we've gone over the basic components of the Keynesian model, I want to spend a little bit of time looking at the math of the system in a little bit more detail. We'll start off by finding the equation for equilibrium output and income, which we'll denote with Y sub E. Recall that for any economy to be in equilibrium, aggregate demand, that is total planned spending in the economy, has to be equal to output and income. And in our simplified economy with no public sector and no foreign sector, aggregate demand is made up of the consumption function plus intended investments. So we can write this as the basic equilibrium condition Y equals aggregate demand, output and income equals aggregate demand, and aggregate demand can be decomposed then into the consumption function here, C bar plus MPCY plus intended investments. Now let's do a little bit of algebra to find what equilibrium output and income is going to be according to this system of equations. We'll start off by subtracting MPCY from both sides. That'll give us Y minus MPCY equals C bar plus I. We've removed the MPCY from the right-hand side here. Since the left-hand side has Y minus MPCY, we can factor Y out, giving us Y times 1 minus MPC is equal to C bar plus I sub I. From there, we just need to subtract both sides by 1 minus MPCY, and this will give us our equation for equilibrium output and income. Again, we'll denote that as Y sub E, the E just standing for equilibrium. Now, this is going to be a very important equation to keep in mind for the quizzes and the next exam, and I want to look at it in a little bit more detail. This equation for equilibrium output and income has essentially two components. That first component there is 1 over 1 minus the MPC. We'll call that the multiplier. The second component then is just the sum of all of our autonomous types of spending. In this case, that's autonomous consumption and intended investments. Note, of course, since the MPC and the MPS have to add up to 1, then 1 minus the MPC is the same thing as the MPS, the marginal propensity to save. So from now on, I'm going to write the equilibrium output and income equation as 1 over the MPS, this is your multiplier, times the sum of autonomous consumption, C bar, and intended investments. So at this point, there's really only 3 equations that you need to be keeping track of, but it will be important that you remember all 3. The first is equilibrium output and income, Y sub E, which we just looked at, and the second we've looked at before, the consumption equation and the savings equation. The consumption equation is given by C bar plus MPCY. The savings equation is very similar, but kind of the reverse. Savings is negative C bar plus MPSY. In calculations that we'll be doing in just a moment, this Y is going to be Y sub E. So we could rewrite these consumption and savings equations as having Y sub E instead of just Y in it, but I won't bother with that here. So let's make some calculations based on just a made-up example with some made-up numbers. Suppose you've got this information. An economy has C bar autonomous consumption of $100, which tells us that even if output and income were 0, there'd still be $100 of autonomous consumption spending, say, as people withdraw money from their savings accounts. The economy also has an MPC of 3/4 or 0.75, which tells us for each additional dollar of income in the economy, there's going to be an additional 75 cents spent on consumption. And finally, the economy has an intended investments level of $300. That just says that given the expectations of businesses and so forth, there's going to be a constant $300 of investment spending in this economy. Now, with this information, you should be able to calculate the following: equilibrium output and income, total consumption spending, and total savings. Let's see how that works. Since the MPC is 3/4, we know the MPS is 1/4 because the MPC and the MPS have to add up to 1. We can take that MPS then and plug it into our equation for equilibrium output and income, and that gives us Y sub E is equal to 1 over 1/4. This is the multiplier components. And then we can plug in our information for autonomous consumption and intended investment, 100 and 300, to get total autonomous spending of 400. So we end up with Y sub E, equilibrium output and income, is equal to 4 times 400, or 1,600. Now that we know what the level of output and income is going to be, we can plug that Y into our consumption and savings functions to find out what the level of consumption spending and the level of savings is going to be. Consumption function, again, is just given by C bar plus MPCY, and we now have all of that information. C bar is 100, MPC is 0.75, Y is 1,600 as we just derived, so we get consumption spending of 100 plus 1,200 or $1,300 total. Savings is given by negative C bar plus MPSY. Negative C bar then is 100, the MPS is 0.25, and again, output and income Y is 1,600. So we get savings of negative 100 plus 400, which comes out to $300. Now, there's a few different ways we could check to make sure that these numbers are adding up and that we are indeed working with an equilibrium solution. If you recall, in equilibrium, total spending, which is consumption and investment spending, must equal total output and income, so we can check for that. Here, output and income came out to $1,600, consumption spending came out to $1,300, and investment was $300. So total spending, $1,300 plus $300, did come out to output and income of $1,600. Another way of checking for this is to recall that in equilibrium, again, the money leaking out of the spending flow through savings must be exactly offset by money injected back in through investment. So savings needs to be equal to investment. Here we found that savings came out to $300 and investment was also $300. So the numbers check out and the economy is in equilibrium.